graphing polynomials. And we know all about how to factor them now, even if it's not just an x squared, and we know how that all relates to the graph, so we can draw graphs. The next piece, we are going to graph rational functions. What are rational functions? We've seen them before when we solved rational equations earlier in the semester. Rational has the word ratio in it. They're fractions. So, we are going to look at what happens when we graph these things. One important thing, we've talked about domains a ton. When you're talking about a rational function, you have a fraction. So your domain is everything except what makes the bottom 0. So usually when we're talking about a rational function, they have it written as like p over q. So whatever makes q 0 is not a part of the domain. Those are the places where our graph is going to do weird things. So that's where we need to be very cautious when we try to graph these. So the first thing we're going to do is just practice finding the domain of a rational function. So we're basically just looking at what makes the bottom 0, and x can't be those numbers. So if I'm looking at this one, what can x not be? -5. That's what makes the bottom 0. We do want to stick with interval notation, so how would I write everything except -5? -5 begins a parentheses since we can't equal that. Union everything bigger than -5, so -5 to positive infinity. B. I want to know what makes the bottom 0 for this one. We know that x squared minus 4 cannot equal 0. So x squared can't be 4. Get rid of a square, you square root, but that puts a plus or minus. So it's x cannot be a positive or -2. I want interval notation, but when you have multiple values that x can't be, interval notation gets a little bulky. You would have to write everything smaller than -2, everything between -2 and 2, and everything bigger than 2. So my general rule is, if it's only one value that x can't equal, give me the interval. If it's more than one, I will let you just tell me x can't be these numbers. So I will not make you write those in interval notation anytime you have more than one value that x cannot equal. All right. C. What would make x squared plus 1 equal 0? It's an I, isn't it? You get plus and minus I. In terms of a graph, do we graph the imaginary numbers? So what would our domain be? Negative infinity to positive infinity. If the number that x cannot equal is imaginary, we're worried about the graph, so x could be anything on our graph. D. What makes 3 equal 0? 3 is never 0, so our domain is again everything. So x can't be anything that makes the denominator 0, but we won't always have something. One thing I want to look at. If I gave you x plus 1 times x minus 1 over x minus 1. would you do to that? Cancel it out. And so we would say that equals x plus 1, right? X minus 1's drop. In terms of the graph, these are actually not equivalent. These are technically different because of the domains. If I'm looking at this one, what can x not be? What's the domain of this one? So, on these, the graphs are different. Because the domains are different. Our graph is always going to be based off the original, not what you would get if you simplify it. It's a very minor difference. We will talk more about it later, but all it is going to be an open circle on our graph. So it's basically going to be a line with a hole in it. But there is that difference. So just keep in mind, if I'm asking you for the domain on one of these, I want it based off the original function. All right. So far, so good? When we graph rational functions, we are going to have a lot of asymptotes. Asymptotes are lines that we get close to without actually touching. We're just continually getting closer and closer. We will look at 3 different types: horizontal, vertical, and oblique. Sometimes the oblique is called a slant asymptote. Basically, it's any line that isn't horizontal or vertical. When we look at the graphs, we will never ever cross a vertical asymptote, but it is possible that we might go through a horizontal or an oblique at some point on our graph. So I want to show you a graph and pick out the asymptotes in this graph to just kind of illustrate what I'm talking about. This is an example of a graph of a rational function. A lot of times we draw asymptotes in as dashed lines. Horizontally, can you tell me where there's the break in this graph? When y is what value? I think it's kind of at 1. If I drew in this dashed line, you see how this graph is getting closer to the 1. This way the graph is getting closer to 1. Where would be the vertical one? 2. Okay, so our graph is getting closer and closer and closer to those without actually touching them. What would be the domain of this graph? So domain is left to right. So this piece. This one went until we got to 2. We didn't cross it, so it gets a parenthesis. This one picks up after 2 and goes forever. The range, what's the only y value we don't hit? 1. Could be negative infinity to 1, union 1 to infinity. What are the x-intercepts? Where's this graph hit the x-axis? 1. If I ask for an ordered pair, it would be 1, 0. Approximately, where does this graph hit the y-axis? Yeah, a half, 2/3. It's kind of hard to tell exactly. I'll always go with 1/2. Or we could say 0, 1/2. So we can kind of tell the intercepts. Horizontal asymptote. So we already said that was at 1. It's a line, so I expect the equation of a line. A horizontal line is what? Y equals a number. So the horizontal asymptote is at y equals 1. Vertical lines are x equals, so the vertical asymptote is at x equals 2. This graph does not have an oblique asymptote. An oblique is basically a line that we're getting close to that's not horizontal or vertical, so it might look something like this if we had an oblique asymptote. So it's just any other line that we would have. So do you guys think if I gave you a graph of a rational function, you could look at it, figure out where the asymptotes were, answer questions about domain and range? So we need to look at what causes these asymptotes. And there's a few things to remember. So this is probably the most important thing we are writing down today. So once you get it written down, put a big star next to it, highlight it, something. This is what you're going to be going back and looking at over and over again. So vertical asymptotes. They are always going to be of the form x equals a number, because it's a vertical line. And that number is what makes the denominator equal 0. So when I look at a fraction and I'm like, oh, I can't put 2 in because it makes the bottom 0, we're getting a vertical asymptote at 2. So it'll always be x equals whatever makes the bottom 0. There may be more than one of these. Okay, horizontal and oblique asymptotes are based off of degree. So what is a degree? The highest power, right? So we're going to compare the degree at the top and the degree at the bottom, or degree of the numerator and denominator. So a horizontal asymptote there's actually different cases. It'll be y equals 0 anytime the degree on top, or the degree of the numerator, is smaller than the degree on the bottom. There's a delay in the board and it keeps messing up when I'm trying to write. Sometimes we will have to divide the leading coefficients. So when I say ratio of the leading coefficients, we have to take the leading coefficient on top and bottom and divide those. And we do that when it is the same degree on top and bottom. Sometimes we get an oblique asymptote. Since an oblique asymptote is any other line, it will be of the form y equals mx plus b. And this happens when the top degree is 1 bigger than the bottom degree. So, based off this, is there a scenario when we could have both a horizontal and an oblique? We get a horizontal if the top has a smaller degree, or if they're the same, we get oblique when the top degree is one bigger. So you will never have both. It's an either or type thing. If the top is more than one bigger, then there is none. So there's no horizontal asymptote or oblique asymptote if the top is more than one bigger. This seems really arbitrary, and I'm going to give you kind of an informal explanation. The real reason that these rules are what they are has to do with calculus, and you would probably just rather I not explain it, okay? But here is kind of an informal reason why these things are what they are. So I told you you get a horizontal asymptote of 0 when the top degree is smaller than the bottom degree. Right? So if I said like 2x over 3x squared plus 1. What's the degree of the top? 1. What's the degree of the bottom? 2. So this is really saying you're dividing these things, right? Can you do 2x and divide by 3x squared? Can you do 3x squared times something and get a 2x? No, we would have to have a fraction. So our quotient is 0 because it doesn't go in evenly, and then you would have your remainder, right? But the quotient is our horizontal asymptote. So in this case, your horizontal asymptote is y equals 0 because you couldn't divide them. The degree on top is too small. When you have the same degree on top and bottom, so if I said like (4x squared over x squared minus x plus 1). Okay, if I go to divide those things, can you do 4x squared divided by x squared? Yeah, what is, if I said 4x squared over x squared, you just get 4, right? And then this wouldn't work out evenly, so we would have our remainder again. But this one has a horizontal asymptote of y equals 4. Since it was the same degree on top and bottom, we divided the leading coefficients, 4 divided by 1. If the degree on top is bigger, then your quotient would have some x's in it. And so then it's no longer just a horizontal line. Y equals a number. Okay, this is a pretty informal explanation. You need to know these rules. We are going to work through a lot, so it will get very familiar. But you need to know when we have which type of asymptote as we go through. So the rest of today, we're just going to practice. We're not even going to graph anything yet. We're just going to look at some equations and see if we can pick out what the asymptotes will be. So we'll practice that a little bit, and then we will stop for today. I don't know if I'll do any obliques today or not. We'll see. Those are a little longer. All right, so let's just practice finding vertical asymptotes first. So all I want is vertical asymptotes. All right, so vertical asymptote, we said, is x equals whatever makes the bottom 0. Very closely related to the domain. So here's the bottom. What makes x squared minus 4 equal 0? Square root plus and minus. So I have two vertical asymptotes on this one. X equals positive 2 and x equals negative 2. I usually just write VA for vertical asymptote. They are equations, so make sure the x equals is an important part of that. It's just like finding the domain, except in the domain, you were telling me x can't be those things when you graph it. And that's because we get an asymptote there. So you're giving me that equation. B, what is my vertical asymptote going to be? X equals 1, because it's what makes the bottom 0. C. We need to know what makes x squared plus 1 equal 0. So that's saying x squared is negative 1. So what do we get? I. Can we graph it? So for our purposes, this means that one has no vertical asymptote. On this one, what would I need to do? Factor. What multiplies to negative 21 and adds to positive 4? So, can you look at that and tell me what the vertical asymptotes are? So what makes x plus 7 equal 0? Negative 7. And x minus 3 equals 0 is positive 3. Are we okay with vertical? Let's practice some finding horizontal and oblique. Okay, so we know it's either horizontal or oblique, it's not both. It's all based off the degree. So what is the degree of the top here? 1. We have an x to the first. The degree of the bottom is 2, because we have an x squared. So the degree on top is smaller. Look at your rules. If the top degree is smaller, what's the horizontal asymptote? Horizontal y equals what? 0. Anytime the top degree is smaller. Let's say I gave you this one. So still finding horizontal or oblique asymptotes. What's the degree of the top? 2. What is the degree of the bottom? 2. When it's the same degree, what did our rule say? Our leading coefficients, that's the 8 and the 4. So this is horizontal. Y equals, what is 8 divided by 4? 2. So if you know your rules, the horizontal asymptote, it's not difficult to find, you just have to know what your rule tells you. Let's say I gave you, let's go ahead and do this one. What's the degree of the top? And the bottom? So same degree means it's a horizontal. Y equals, we divide the leading coefficients. Leading coefficient of the top is 3. The bottom, this is just a 1x, so 3 divided by 1 is 3. Are we doing okay with those? I want to do this one. What is the degree of the top? 4. What is the degree of the bottom? 3. So when the top degree is 1 bigger, what does that tell me? It's an oblique. Oblique are a little more difficult to find. So the explanation I gave you for the horizontal ones involved long division, right? We divided and I basically just looked at the quotient. I ignored the remainder. That's what we're going to do here. We're going to set up long division. The good news is we don't have to do the whole thing. We're just trying to get the equation to align. So the top is what goes underneath. If you want to include a 0x cubed, because we don't have that as a placeholder, you're welcome to. It's kind of up to you. You know, if you want the 0x and the 0, you can have those. You don't have to. And this goes out here. I'm only going to kind of do one long division example today, but we will look at more tomorrow. So the good news is, we're just trying to get the equation aligned. Y equals mx plus b, right? Once I have that, then I have my oblique asymptote. So let's figure out what it is. You start by dividing. What is 3x to the 4th divided by x cubed? Yeah, let's think. 3x to the 4th over x cubed, so you would cancel, we get a 3x. Then you multiply, so you have to take 3x times this entire thing. So 3x times x cubed is 3x to the 4th. 3x times negative x squared is negative 3x cubed. 3x times 0x is 0x squared. 3x times 1 is 3x. Do you remember what we have to do here? Subtract. So we usually just ran a negative through, changed all of these signs. But we are really close, guys. We're almost done. So these cancel. 0x cubed plus 3x cubed is 3x cubed. Minus x squared minus 3x. You can bring down plus 0 if you want. Now we're back to the beginning, so we divide. What is 3x cubed divided by x cubed? 3. Notice, we wanted y equals mx plus b, 3x plus 3. That's all I need. I don't have to finish the long division. So my oblique asymptote is y equals 3x plus 3. Did I lose anybody there? So, when you do long division, it's basically a 3-step process. You divide, multiply, subtract. And then we repeat that process. So we divided the first things. 3x 4th divided by x cubed. We got our first number. Then we multiply. So we take 3x times this whole thing. That's where that expression came from. Then we subtract. So we ran our negative through and combined those. Then we're back to the beginning. So we're back to the divide. So 3x cubed divided by x cubed That gave me the 3, and that was all I needed. And this will always be a line. So your first term will always have something with an x. Your second one will always be a constant, and then you're going to stop every time. Okay. I'm stopping here for today. We will definitely practice more with the oblique tomorrow, and we'll start looking at the graphing some. So let's do okay. 9 through 16, they just have you looking at some graphs and answering some questions. 37 through 45, you are asked to find asymptotes. You're only doing the odds on those, and then the last couple are again looking at graphs and answering questions.